Hey friends, welcome to the YouTube channel all about electronics. So in this video, we will learn about the 2's complement arithmetic and we will see that how to perform the addition and the subtraction of the signed binary numbers using this 2's complement method. So the addition in the 2's complement form is very similar to the unsigned binary numbers. So just add the two numbers and if there is any carry after the addition, then just ignore it. And in this way, the result which we are getting is the correct result, except whenever we get the overflow. So later on, we will see that when this overflow condition can occur. But first of all, let us see the different cases that can occur while adding the two signed numbers in the 2's complement form. And for understanding, let us take 5-bit signed binary numbers as an example. So during the addition, the first case is when the both numbers are positive numbers. Let's say we want to add this plus 6 and the plus 7 using the 5 bits 2's complement arithmetic. So first of all, let us represent this plus 6 and the plus 7 in the 5-bit form. So this plus 6 can be represented as 00110, where this MSB is the sign bit. Similarly, this plus 7 can be represented as 00111. And as I said, the addition is very similar to the addition of the two unsigned numbers. That means we will do the column by column addition. That means here this 0 plus 1 is equal to 1, while this 1 plus 1 is equal to 0, and there will be a carry of 1. And if we add this 1 plus 1 plus 1, then the result will be equal to 1 and the 1 will be the carry. So once again, in this column, this 1 plus 0 is equal to 1. And in the last column, this 0 plus 0 is equal to 0. That means after the addition, the result is 01101. So as you can see here, since the MSB is equal to 0, that means after the addition, the result is positive. And if we convert into the decimal equivalent sign number, then it is equal to plus 13. So in this way, we can perform the addition of the two positive numbers. Now in the previous video, we have seen that using the n bits, the range of number that can be represented in this 2's complement form are from minus 2 to the power n minus 1 to 2 to the power n minus 1 minus 1. So for the 5 bits, it is in the range of minus 16 to plus 15. So after the addition, if the number is out of this range, then we will get the invalid result, or it is the case of the overflow. So through the example, let us understand the case of the overflow. So let's say we want to add the two numbers plus 9 and the plus 7 using the 5 bits 2's complement arithmetic. So first, let us represent these two numbers in a 5-bit form. So this plus 9 can be represented as 01001. Similarly, this plus 7 can be represented as 00111. And if we add these two numbers, then this 1 plus 1 is equal to 0 with 1 as a carry. Similarly, this 1 plus 1 is equal to 0 and the carry is equal to 1. Likewise, this 1 plus 1 is 0 and the carry is equal to 1. Once again, this 1 plus 1 is 0 and the 1 is the carry. Therefore, after the addition, the number is 10000. And after the addition, the result which we are getting is in fact invalid. The reason is that the addition of the plus 9 and the plus 7 is equal to plus 16. And as you have just seen, using the 5 bits, the maximum number which can be represented in this 2's complement form is equal to plus 15. Therefore, this addition will be always invalid. And even just by looking at the binary addition also, we can decide that whether this addition is correct or not. So if we just look at the signed bits of these two numbers, then it is equal to 0. On the other hand, if we see the sign bit of the result, then it is equal to 1, which indicates that the number is negative. Now here, we are adding the two positive number. Therefore, the result has to be positive. Or in other words, after the addition, the MSB of the result should also be equal to 0. But in this case, the MSB of the result is equal to 1, which indicates that this result is invalid. That means whenever we are adding the two positive numbers whose result is beyond the range of this n bit 2's complement representation, then we will get the invalid result, and it is the condition of the overflow. Alright, so now let us take the second case where the one number is positive and the other number is negative. And first, let us consider that this positive number is greater than negative number. So let's say we want to add the plus 13 and the minus 6 using this 2's complement arithmetic. Now this minus 6 is in fact the 2's complement of the number plus 6. So in a 5-bit form, this plus 6 is equal to 00110. So if we just take the 2's complement of this number, then we will get the minus 6. So in the previous video, we have already seen the different ways for finding the 2's complement. The one way is, first of all, find the 1's complement of the number and then just add 1 to this 1's complement. So for the 1's complement, just flip all the zeros with the 1 and 1's with the 0 in the given number. And then if we just add 1 to that 1's complement, then the result is 11010, which is the 2's complement of the number plus 6. Or in other words, this is how the minus 6 can be represented in the 2's complement form. Alright, so now this plus 13 can be represented as 01101. And as we have seen, this minus 6 is equal to 11010. So if we add these two numbers, then this 1 plus 0 is equal to 1, while similarly this 0 plus 1 is equal to 1. In the next column, this 1 plus 0 is equal to 1, while this 1 plus 1 is equal to 0 with 1 as a carry. So in the last column, this 1 plus 1 is equal to 0 with 1 as a carry. So here we will ignore this carry. So now if we see the result, then it is equal to 00111. And here as you can see, the MSB is equal to 0, which indicates that the number is positive. And if we see the decimal equivalent, then it is equal to plus 7. So this is how we can do the addition of the one positive number and the one negative number. So in this case, the positive number was greater than negative number. Now let us see the second case where this negative number is greater than positive number. So let's say we want to add this minus 15 and plus 9. So first of all, let us find the equivalent representation of this minus 15 in the 2's complement form. So in a 5-bit form, this plus 15 can be represented as 01111. And to find the 2's complement, first of all let us take its 1's complement. That means just by inverting all the zeros by 1 and 1's by 0, we will get the 1's complement, which is equal to 10000. And now if we just add 1 to it, then the result is 10001. So this represents the 2's complement of the number plus 15. Or in other words, it represents the minus 15 in the 2's complement form. So now we know that this minus 15 can be represented as 10001, while this plus 9 can be represented as 01001. So now if we just add these two numbers, then this 1 plus 1 is equal to 0 with 1 as a carry. So now this 1 plus 0 is equal to 1, and in the next column this 0 plus 0 is equal to 0. Similarly in the next column, this 0 plus 1 is equal to 1, while this 1 plus 0 is equal to 1. So here as you can see, this MSB is equal to 1, which indicates that the result is negative. So this is the correct representation in a 2's complement form. So if we just take the 2's complement of this number, then we will get the corresponding positive number. Now in the previous video, we have also seen the easy way of finding the 2's complement. So starting from the LSB, copy all the bits until we encounter the first one, and then after replace all the zeros by 1 and 1's by 0. That means if we see the 2's complement of this number, then it is equal to 01100. So until we encounter the first one, copy all the bits as it is, and after this first one, replace all the zeros by 1 and 1's by 0 in the given number. That means the 2's complement of the number is equal to 00110, and its decimal equivalent is equal to plus 6. Therefore, this number corresponds to minus 6. And in fact, which is our expected result, right? Because the addition of the minus 15 and the plus 9 should be equal to minus 6. So similarly, now let us see the case when the two numbers are negative. So let's say we want to add the two numbers, that is minus 8 and minus 4. So first of all, let us represent this minus 8 and the minus 4 in the 2's complement form. So we know that the plus 8 in the 5-bit form is equal to 01000. So if we find its 2's complement, then it is equal to 00011. That means starting from the LSB, copy all the bits until we encounter the first one, and then after replace all the zeros by 1 and ones by 0 in the given number. That means the 2's complement of this plus 8 is equal to 11000. Similarly, this plus 4 in a 5-bit form can be represented as 00100, and its 2's complement is equal to 00111. So in this way, we found the 2's complement representation of this minus 8 and minus 4. So now let us just add this minus 8 and minus 4. So if we perform the addition, then this 0 plus 0 is equal to 0. Similarly, in the next column, this 0 plus 0 is equal to 0. Then this 0 plus 1 is equal to 1, while this 1 plus 1 is equal to 0 with 1 as a carry. And in this last column, this 1 plus 1 plus 1 is equal to 1 with 1 as a carry. So here we will ignore this carry bit. So after ignoring the carry bit, if we see the result, then it is equal to 10100. So here as you can see, the MSB is equal to 1, which indicates that the number after the addition is negative and it is in the 2's complement form. So if we take the 2's complement of the number, then we will get the corresponding positive number. So if we just take the 2's complement, then its 2's complement is equal to 00110, and the corresponding decimal number is equal to plus 12, which indicates that this number is equal to minus 12 in the 2's complement form. That means this number represents the minus 12 in the 2's complement form. Now here after the addition of the two negative number, the result is still within the 2's complement range, because for a 5-bit 2's complement form, we have seen that the range is from minus 16 to plus 15. But after the addition, if the result goes beyond this range, then the condition of overflow will occur, or we can say that in that case the result is invalid. So let us take one example where the addition of the two negative number goes beyond the 2's complement range. So let's say we want to add the two numbers, that is minus 8 and the minus 9, using the 5 bits 2's complement arithmetic. Now as we have seen, using the 5 bits, we can represent the numbers starting from minus 16 to plus 15 in a 2's complement form. So if we add the minus 8 and the minus 9, then the result is equal to minus 17. And as you can see, it is beyond the range of 5-bit 2's complement form. That means in this case, if we add these two numbers in a 5-bit form, then we will get the invalid result. And the same thing, let us also see that in a 2's complement form. And for that, first of all, let us represent this minus 8 and the minus 9 in a 2's complement form. So we know that the plus 8 can be represented as 01000. So its 2's complement is equal to 00011. Similarly, this plus 9 can be represented as 01001. So its 2's complement is equal to 11101. So in this way, we found the 2's complement representation of minus 8 and minus 9. So if we try to add these two numbers, then the result is 10111. So here, if we just ignore this carry bit, then the result is 01111. So as I said earlier, just by checking the MSBs, we can decide whether the addition is correct or not. So here if you see, then the MSB of the two number is equal to 1. That means the two numbers are negative. On the other end, if we see the MSB of the result, then it is equal to 0, which indicates that the result is positive. Now whenever we are adding the two negative numbers, then the result should also be negative, right? But here we are getting the positive result, which indicates that this addition is invalid. That means while adding the two numbers in a n bit 2's complement form, we also need to be careful about the range. Alright, so now let us see how to perform the subtraction using the 2's complement arithmetic. So this subtraction in this 2's complement arithmetic is very similar to the addition. Let's say we want to subtract the 3 from 5, which is equivalent of saying the addition of the plus 5 and the minus 3. So in the 2's complement arithmetic, it is equal to 5 plus 2's complement of the number 3. So we know that in a 5-bit form, this plus 3 can be represented as 00011. So its 2's complement is equal to 10111, which indicates minus 3. So now to perform the subtraction, we need to add this minus 3 and plus 5. So this plus 5 can be represented as 00101. And as we have seen, this minus 3 in a 2's complement form is equal to 11101. So if we perform the addition, then this 1 plus 1 is equal to 0 with 1 as carry. So in this next column, this 1 plus 0 is equal to 1. So then after, if we move to the next column, then this 1 plus 1 is 0 with 1 as a carry to the next column. So once again, this 1 plus 1 is 0 with 1 as a carry to the next column. And in the last column, this 1 plus 1 is 0 with 1 as a carry. So here we will ignore this carry bit. So after ignoring this carry, if we see the equivalent number, then it is equal to 00010. And as you can see, here the MSB is equal to 0, which indicates that after this addition, or in other words, after this subtraction, the resultant is positive. And if we see the decimal equivalent, then it is equal to plus 2. So in this way, using this 2's complement arithmetic, we can also perform the subtraction similar to the addition. So similarly, let's say we want to subtract this minus 6 from plus 9, which is equivalent of saying the addition of plus 9 with the 2's complement of the number minus 6. Now we know that the 2's complement of the negative number is positive. That means the 2's complement of minus 6 is equal to plus 6. So to perform this subtraction, we just need to add this plus 9 with plus 6. And if we see the equivalent number, then it is equal to 0111. And the corresponding decimal number is equal to plus 15. So in this way, using this 2's complement arithmetic, it is very easy to perform subtraction just like a addition. Alright, so now let us take this last example. So let's say we want to subtract these two numbers using this 2's complement arithmetic. And here both numbers are in a 2's complement form. So let's say these two numbers are p and q respectively. So in a 2's complement arithmetic, this p minus q is effectively p plus 2's complement of the number q. So first of all, let us find the 2's complement of the number q. So if we find the 2's complement, then it is equal to 10011, and effectively it is equal to minus q. So now let's add p to this minus q. So if we perform the addition, then this 1 plus 1 is 0 with 1 as a carry to the next column. Then in the next column, this 1 plus 1 plus 1 is equal to 1 with 1 as a carry to the next column. So now in this third column, this 1 plus 0 is equal to 1. Then in the fourth column, this 0 plus 1 is 1, while in the fifth column, this 1 plus 1 is 0 with 1 as a carry. So if we ignore this carry bit, then the result is 01110. Now let's see whether our addition is correct or not. So if you see the MSB of the two number, then it is equal to 1, which indicates that the two numbers are negative. On the other end, the MSB of the result is equal to 0. So as I said earlier, when we add the two negative numbers, then the result has to be negative. That means the MSB of the result should also be equal to 1. But in this case, as you can see, it is equal to 0, which indicates that the result is invalid. So let us understand why we are getting this invalid result. And for that, let us find the decimal equivalent of the given numbers. So here, both numbers are in a 2's complement form. And in the first number, the MSB is equal to 1, which indicates that the number is negative. So if we find the 2's complement of the number, then we will get the equivalent positive number, that is equal to 10100, which corresponds to plus 5. That means the given number is equal to minus 5. Likewise, the second number is equal to 01101, and in decimal it is equal to plus 13. So here what we are doing, we are subtracting this minus 13 from minus 5, and therefore the result should be equal to minus 18. But as we have seen, in a 5-bit 2's complement form, the range of number that can be represented are from minus 16 to plus 15. That means this minus 18 is out of the 2's complement range, and therefore we are getting the invalid result. But suppose for the same numbers, if we do the 2's complement arithmetic in a 6-bit form, then we will get the correct result, because in a 6-bit representation, the result is within the given range. So let's perform the same arithmetic in a 6-bit form. And first of all, let us represent both numbers in a 6-bit 2's complement form. So if we try to represent these numbers in a 6-bit form, then we need to copy the MSB of these two numbers in a additional bit. So this is how these two numbers can be represented in a 6-bit form. So here we have just copied the MSB of these two numbers in the additional bit. So by doing so, the number remains the same. So now let us find the 2's complement of this second number, that is equal to 110011. So instead of performing the subtraction, now we need to add these two numbers. And if we try to perform the addition, then it is equal to 1101110. So if we just ignore this carry bit, then the result is 101110. And here as you can see, the MSB is equal to 1, which indicates that the number is negative. So if we just take the 2's complement of that number, then we will get the corresponding positive number, that is equal to 010010, which is equal to plus 18. That means this number corresponds to minus 18 in a 2's complement representation. So as you can see, now in a 6-bit form, we are getting the correct result. That means while performing the addition or the subtraction in this 2's complement form, we should always be careful about the range. So these are the few things which we need to keep in mind during the 2's complement arithmetic. But I hope through the different examples, you understood how to perform the addition and the subtraction using this 2's complement arithmetic. So similarly, in the future videos, we will see that how to perform the addition using the 1's complement arithmetic. So if you have any question or suggestion, then do let me know here in the comment section below. If you like this video, hit the like button and subscribe to the channel for more such videos.